It is a tactile telerobot that can transmit realistic touch feedback to an operator located anywhere in the world. Welcome back to Techstination. I'm Fred Fishkin. Converge Robotics Group has reached the finals of the $10 million ANA Avatar XPrize competition. It's using technology developed by Shadow Robot. And joining us is Shadow Robot Managing Director Rich Walker. Thanks for taking the time, Rich.
Thanks, Fred. An absolute pleasure.
Well, give us the overview of what you've been building and its significance.
Sure. So Shadow is, I guess, an unusual team. We came together over 20 years ago as a bunch of people who had fun building robots, and we found that people liked what we were doing, and they wanted to pay us to do more of it, which is always an enviable position to be in. So what we got really into was building hands for robots. The human hand is a real marvel. It's just incredibly dexterous, agile. It has a huge number of sensations and ways of telling what's going on, and it packs that into this very, very physically small form factor. It doesn't look so impressive until you try and build a mechanical one, at which point you realize just how much is going on in your hand. So over 20 years, we've been building these robotic hands, and about 2-3 years ago, we were approached by our colleagues who now make up the Converge Robotics team, and they said, hey, we should be putting something together for this avatar competition. We have the Shadow robot hands, we're working with people who build fingertips to give it a sense of touch, and we're working with haptics who have a way of capturing the human hand that we can then translate into the robot hand. So we put that together to build something that at the time we thought was pretty much the first in the world, which is a system that genuinely lets you touch and feel what's going on in a different place.
So give us a for instance and some of the use case possible scenarios here.
Sure. So one area that we've been working with a lot of people in is nuclear. A lot of nuclear engineering takes place in dangerous and unpleasant places, as you can imagine. You can wear protective equipment sometimes, but you're still likely to get some level of exposure from doing that. So instead, if you use a robot hand that has the same movements as your hands would, and you control that from the other side of a wall, the other side of a building, then you can be in a much safer, a much less exposed location. On the other side of the scale, sometimes you're not trying to protect the work. So on the other side of the scale, sometimes you're not trying to protect the human from the work, you're trying to protect the work from the human. And we're doing some work with some pharmaceutical companies who try and maintain very, very sterile manufacturing plants. They don't want to contaminate anything they're manufacturing. And there, when a human has to intervene, the human produces risk to the actual chemicals being made, the pharmaceutical products. So if the robot hand is there and can do the tasks the human can do, master-slave symmetry, then we can remove the need to put a human in that machine, in that environment.
Is, I guess, what gamers would call latency an issue here?
That's a really interesting question. Lots and lots of work has been done on making robots operate over distances, and there are some absolutely fascinating papers on how can you get a surgical robot that you can operate over a wireless link or a phone link or something. So we were very concerned that latency would be a challenge, a barrier for us. Then we actually tried hooking up a system from London to San Francisco over a mobile phone connection. And we found that quietly, while no one was looking, the internet had just kind of got good enough that unless you happen to hit a bad patch, the internet's basic connections are pretty fast now. And that kind of thing works really, really well. So yeah, you can get bad latency, but we treat it as weather. We have a little dial that tells you how long the latency is. And you wouldn't climb a ladder on the outside of your house on a windy day. Well, in the same way, you probably wouldn't want to do a precise manipulation task when you've got 1 second of latency, let it drop back down again, or find a better Wi-Fi connection, and then it's not really an issue.
Now, robotics have found their way into medicine, I guess, in a pretty big way. So tell us, are you playing in that space as well?
We've done a little bit of work with the Mayo Clinic, interestingly. So they do what they call remote GP practice, remote diagnostics. So imagine you go to your local healthcare center and you've got something, and the staff there take a look at it and they're like, oh, we don't know what that is. So they can get someone from Mayo on essentially an iPad, and they can talk to you and say, well, what is it? What is it? That's it. Okay. Nurse, can you just poke it like that and see, how does it feel, kind of things. What we've been talking to with them is doing the same thing, but instead of having just the iPad, having a hand that you can control remotely. So the remote doctor can say, right, okay, I will actually pull your eyelid down, have a little peer under it at the camera. Nurse, can you just move the camera? Yeah, okay, I can see that. Thank you. What about that bit? And actually get a sense of touch, a sense of contact. And we did some tests with Mayo where amongst the other tests we did, we used an ultrasound probe remotely. And so the doctor at Mayo was able to verify that one of our engineers actually had a heart, which was a great relief to him and a surprise to most of us.
Well, tell me what led you into this.
So we started building hands for robots, basically because it was a challenge. We knew that people were trying to build interesting robot technology, and we looked around at what was there and what wasn't there. And we realized that no one had really tried to build anything much like a human hand. And we like a challenge. So we started. The first one we built back in 1998, 99, so over 20 years ago. It was wooden. It was pretty much held together with string and elastic bands and hot melt glue, but it was good enough to be able to pick up a straight side of glass, in fact, an English pint glass with beer in it. From there, we got the idea of building some better and better ones until we got to the kind of really nice products that we do today. But this was always done with the idea that you could push the boundaries of what was possible if you had better hardware to do it. And robotics hardware in the area of hands wasn't good enough yet. So we built these amazing robot hands. And then we worked with people doing absolutely fascinating research to understand how they can take these robot hands and use them.
Do you envision a time when your technology might be used in robots that are moving around offices, homes, and actually doing things with their hands that maybe we'd like them to be doing?
Oh, sure. So one of the goals from the ANA Avatar XPrize is actually to start to build out robots that can be used instead of people by people. I don't know if you know the backstory, but one of the things that the Avatar organization was doing was they put some robots in a cafe, and they had patients who were bedbound operating those cafe robots to serve people in the cafe, unless they were able to actually do a job and earn a living while still being bedbound, which is pretty impressive in itself. So that kind of piece is already possible in the jigsaw. Getting a robot that's wandering around your home and doing household tasks, yeah, that will happen eventually. Obviously, the first, second, third generation of these things are going to be expensive, high-end items, but I think eventually the price will drop. And bear in mind that the first cars were not very cheap, but now a car is something every household has 1, 2, 3, 4 of.
What are some of the biggest challenges that you feel you still have to overcome, whether it's in the area of engineering or otherwise?
It's really hard to see things well. We've had 60, 70 years of computer vision working on the problem of how do we see the world reliably and well, and it turns out to just be stunningly difficult. We solved chess first. That will give you some idea of how hard computer vision is. And really seeing objects and understanding what they are and being able to see things just as well as a human sees things is incredibly difficult for robots. So that cracking that will be a big step. Don't get me wrong, the technology is there and it gets better and better and better, but it's still not at the point where for a general robot doing anything, you can rely on it. If you want to recognize handwriting characters, we can do that now with computer vision, but actually seeing and understanding objects in the world is still really tricky. And of course, the other challenge is batteries. Whilst we've seen generations and leaps and bounds of improvements of batteries over the last 20 years as mobile phones have come in and then electric vehicles have come in, we're still limited in the ability to put a robot together that can do a full day's work.
It sounds like you're talking about the exact same challenges that face companies trying to build autonomous cars.
An autonomous car is a robot. We just don't bother calling it that anymore because we tend to reserve the word robot for a 6-7 degree of freedom industrial arm that picks things up and puts them down. But they all come from the robotics technology area. And when you look at who autonomous car companies hire to do the engineering work, they're people with degrees in robotics.
For more information on what you're doing, where's the best place for people to go?
So if you go to the Shadow website, shadowrobot.com, we have a whole bunch of stuff there around the stuff we've been doing around building hands and some of the more interesting challenges we've tried with that. And you can see some demonstrations of the Tele-Robot system in action. We often turn up at shows and events as the world's now opening up again. We've just been to a big event in Dubai, and we hope to get some more in later in the year in the US.
You know, every now and then you see stories about this. Should humans be fearing robots? Maybe Hollywood has done too much to make us afraid.
I think Like any piece of machinery or technology, the question is not should you fear the machine. You might have to treat it with healthy respect because it's a big piece of machinery that can do things and it's strong and powerful. But what you fear is the systems that the machines get built into, whether that's political or economic systems. The risk from AI is not that an AI will become super smart and take over the world. The risk from AI is that an AI will be deployed to change social discourse and drive our politics into a place where we don't want to get it. And that we're already seeing happening. It's not the robots that are the problem, it's the algorithms controlling our news feeds.
It's the people behind it.
Yeah.
We're writing the code. Again, it's shadowrobot.com is the website.
Yeah. Shadowrobot.com.
Rich Walker, thank you so much for taking the time with us.
Thank you, Fred. An absolute pleasure. Talk soon.